In the fastest measured tennis serve, the ball left the racket at 75.14 meters per second. A served tennis ball is typically in contact with the racket for 30.0 milliseconds and starts from rest. Assume constant acceleration. How far did the ball travel during the serve? So let us first have the given from the problem. So we have 75.14 meters per second. The 75.14 meters per second will be actually the final velocity of the tennis serve, because we will just be analyzing the ball in contact with the racket. So the ball is only in contact with the racket at a time of 30.0 milliseconds, and assuming that when the ball is in contact, it started from rest. Therefore, the initial velocity is 0 and the final velocity is 75.14 meters per second, and the time is 30 milliseconds, 30.0 milliseconds, or this is equal to 30.0 times 10 raised to negative 3 seconds. Okay, and starts from rest. So these are all the given from the problem. We are required to get the displacement. How far did the ball travel during the serve? Okay, so we are asked to get the displacement of the tennis ball. So let's try to solve for this problem for our solution. So we need to analyze what equation from kinematic equations we need to use for this problem. So for us to get x, we can use the equation x is equal to v initial t plus 1/2 a t squared. But our initial velocity is 0. So this term will just be 0. And x therefore will just be equal to 1/2 at squared. So we are looking for x. We already have the time equal to 30.0 milliseconds, or 30.0 times 10 raised to negative 3 seconds. But we don't have yet the acceleration. Let us first find the acceleration of the ball because of the racket hitting the ball with a span of 30.0 milliseconds. So if we are to remember our acceleration equation, acceleration is v final minus v initial all over the elapsed time, the period where the change in velocity happened. So the final velocity according to the problem is 75.14 meters per second. 75.14 meters per second, and the initial velocity is 0 all over the time, which is equal to 30 times 10 raised to negative 3 seconds. So the acceleration now of this ball will be equal to, so 75.14 minus 0 is 75.14 divided by 30 exponent negative 3. So the answer is 2504.67 meters per second squared. So this is how fast the racket gives an acceleration to this tennis ball. Now let us find the distance traveled by the ball when the racket hit this tennis ball and gives it an acceleration of 2504.67 meters per second squared. So let us now substitute this acceleration to our equation. X is equal to 1 half at squared. This is equal to 1 half times 2504.67 meters per second squared multiplied by 30 times 10 raised to negative 3 seconds squared. Let us see how much this is the displacement of the tennis ball. So 2504.67 times 0.5, 1 half, times 30 exponent negative 3 squared. So the displacement of the ball is 1.1271 or approximately 1.13 meters. Okay, so when the tennis ball or when the racket hits the tennis ball, it was in contact with the tennis ball in 30 milliseconds. It is in contact until at this distance 1.13 meters. After 1.13 meters, the ball is no longer in contact with the racket, and that velocity when the ball leaves the racket is 75.14 meters per second. So our answer for the displacement of the ball during this problem is 1.13 meters.